This our class have 6 class talk about the other province from the first at Sulawesi Selatan or South Sulawesi, and the second is Central Java, and the third is about Maluku, and the fourth is talking about the Papua West Papua or Papua Barat. The fifth is talking about, I think it's Lampung or from the Sumatra, and the last our group or discuss about the project in Kalimantan or South Borneo. So it's your best time to expand or closing our this event. So giving your chance to expand your project. Okay, thank you very much.
Thank you for Mr. Rizal Asri. Good morning, ladies and gentlemen. We are here. We're very glad get opportunity to deliver today's presentation. The presentation will be held by me, Rizal Hadi, and next to me is Mr. Pinto Anugrah. The presentation is about LEAP project in South Borneo. We are the student of Magister of System Engineering of Gajah Mada University. Let we begin with the opening statement. The profile of South Borneo Province. South Borneo Province astronomical placed in 114 degree 19 minutes 13 second until 116 degree 33 minutes and 28 second in east, and 1 degree 21 minutes 49 second until 4 degree 10 minutes 14 second in south, which in boundaries in west you can find Central Borneo Province, in east you can find Makassar Strait, and in south you can see Java Sea, and the north is East Borneo Province. Area of South Borneo is about 37,530.52 square kilometers. It consists of 11 regency and 2 cities. The capital city is in Banjarmasin, but the administrative city is in Banjarbaru. Population based on 2011 data is 109,557 people. Then the electrification ratio is about 70.53%. It's based on 2011 data. So, as we know, the South Borneo has a lot of coal, and the coal is the main resource of power plant in Indonesia. It's such area in South Borneo is often to get outage power. So, with this project, we have opportunity to get an improvement of energy policy in South Borneo. But the aim of this project, of course, first is to describe energy balance of South Borneo province. It's in electricity only. The second is simulate energy planning scenario until 2015 using this assumption. First, 100 electrification in 2025. And second, increase renewable energy installation. How about the data? The data we can approach is a secondary data. We can find from population, gross domestic product, electricity, existing power plant, electricity consumption, energy development planning. The data came from many resource such as BPS, PLN, ESDM, RPJMD, and RPGPD. It's from the province of the government of province South Borneo. So, to make a project, we need a software tools. What kind of software tools that we need? First is Microsoft Excel, and second is LEAP, or you can, the abbreviation is about Long Range Energy Alternative Planning. And for the assumption, the base year is 2011, and end year is 2050. Based on this scenario, there are three diagrams, as you see in there. There are two scenarios. First, inshallah scenario, or you can say it's expected scenario, and then alhamdulillah scenario. It's similar with this scenario. Beside that, you can find dasar. Dasar is BAU, business as usual. This scenario there are three kinds of scenario, as I have to tell you before. They are K assumption for dasar. It's about GDP growth. It's about 6%, and in the message, and below poverty level is about 2%. Low economic 38%. Middle economic is reminder, and for high economical is 20%. For the inshallah scenario, the K assumption is about 77%, and in demand side, household share below poverty level is about 1%. Low economic is about 20%. Mid economic is as a reminder, high economic in 39%. And for a alhamdulillah scenario, the K assumption, the GDP growth is about 5.5%. Household share-nya same as dasar, or we can say it's below poverty about 2%. Low economic is 38%. In middle economic is as a reminder, and high economic is 20%. Also about the supply side. The supply side is about the transformation. We can say in dasar first. For the dasar, you can look and hear here. For the steam power plant, we had 2013, 2015, 2017, and 2018. Its growth increasing. It means we need to build some steam power plant. And for the still in dasar scenario, PLTG gas, you can find in 2013, 2016, 2021 is also grows. It's about 21 megawatt to 221 megawatt in 2016, and in 2021 is 271. Okay. For the water is in 2013 and 2022. It's based our discussion about how to make the transformation. For inshallah scenario, it's more complicated from the dasar. For PLT, for the steam power plant, you can find it from 2013 till 2040. It increased rapidly. It's about from 260 and 350. It's all in time. Inshallah scenario is make some transformation too for water for water, for for solar cell, for PLTB, panas bumi, and PLTB biomass. It's increasing the power plant we can build till 2040, the last year, of building power plant. And for Alhamdulillah scenario, it's same with dasar for steam power plant, for gas same with dasar, and same as inshallah for water and biomass. So the next presentation will be held by Mr. Pinto to tell you about demand and supply and how the transformation about. Thank you.
Thank you for the time, Mr. Rizal Hadi. I'm afraid we don't have much time left, so we will continue to the results and discussions after we conduct the project using LIP software tools. So this is the energy demand in South Borneo, Kalimantan Selatan. You see that Mr. Rizal Hadi has already mentioned that we divided the sector into three: rumah tangga, public and industry. Rumah tangga, which is household. So you see that the energy demand of Kalimantan Selatan, South Borneo province is gradually increasing, which the highest one is from public sector. The highest increasing from public sector due to the GDP, which is about 8,000 million rupiah in public sector. I'll explain each sector starting from rumah tangga or household. So we divided the sector into 4 category: below poverty level, which is di bawah garis kemiskinan, the low economic, middle economic, and the top 20%. So mostly that the energy demand comes from the middle economic sector, from household. And you see that the currently existing level of di bawah garis kemiskinan or below poverty level is only 2% of currently inhabitants of Kalimantan Selatan or South Borneo. We go ahead to public sector. Only 2 categories here: commercial and social. Commercial is like a hotel, a mall, a restaurant, and something else, where the social sector is a praying place like mosque, a church, and something. Most of the energy demand goes to the commercial category in this public sector. Next, we continue to industrial sector. The non-metal category consume the majority of the energy demand in this industrial sector, whereas the others goes to food industry, makanan, the chemical industry, and the wood, kayu, the wood industry. Basically, the industrial and the public sector has the same calculation. So the variable that influence the energy consumption on these 2 sectors goes from the gross domestic product or GDP of Kalimantan Selatan or South Borneo province. So if we put it all the 3 sectors together in one graph, you see that still the most energy demand comes from commercial side, and the rest is you can see that from the graphs. So what's the point of this scenario? So we compare these three scenario, the dasar, insyaallah, and alhamdulillah, and basically the difference is only in terms of the GDP and the GDP growth and the inhabitants growth, population growth. So this is why the insyaallah in insyaallah scenario, the energy demand will go higher than dasar and alhamdulillah scenario. On the other hand, we use we calculate the transformation in terms of electricity generation. Currently, there are 4 power plants in South Borneo, PLTU, coal or steam power plant, which is contribute to the most electricity in South Borneo province. The next is gas power plant and diesel power plant and hydro power plant. Note that in the diesel power plant, we only calculate the ones that run by the PLN, the National Electricity Company, not from the rented one or the household-owned diesel power plant. What about the insyaallah scenario? We input some of the renewable energy penetration, like solar energy and wind turbine, also the biomass energy. We see that the electricity generation wasn't too much different with the dasar scenario, but one point is that the steam power plant is slightly reduced, not slightly, but a lot of reduced compared to the dasar scenario, and I'll explain it later. So going to alhamdulillah scenario, the result is here. We the only renewable energy in this scenario is biomass and hydropower plant. If we compare these 3 scenario, a little bit different. That alhamdulillah scenario will overlap the dasar scenario in electricity generation due to its electricity demand. That in alhamdulillah scenario, the electricity demand is slightly lower than the dasar scenario. So even though their electricity generation is more than alhamdulillah scenario, but the alhamdulillah scenario has less electricity demand. So that's why the electricity generation in this graph shows otherwise. So what's the point of comparing the demand sector and demand side and supply side in energy transformation? So this one I would like to show you is how is the energy mix in South Borneo province. In dasar scenario, we compare to period, the first year and the end of year scenario, 2015, which is the existing condition. You see that 46.7% of the electricity comes from steam power plant, whereas if you don't do anything, which means business as usual, the steam power plant will even getting more production, which contribute to 66.9%, equal to 67% of all the power plant in South Borneo. So in insyaallah scenario, otherwise we input the renewable energy. There are some penetration of renewable energy in this province. You see that still the coal power plant are the majority, but you see that the percentage are much lower than the dasar scenario. 39.6% of steam power plant, while the rest goes to gas power plant, diesel, and various renewable energy. What about the Alhamdulillah scenario? Alhamdulillah scenario, I believe that this could not help much to reduce the steam power plant consumption, generation. So to easily understand what are our main topic today is by using this table, we conclude this into one table. The electricity demand compared to these three scenarios in 2050 is 6,200 gigawatt hour in dasar skenario, 7,400 gigawatt in inshallah skenario, and while the alhamdulillah skenario, the least one, around 5,900 gigawatt hour. That's from the demand side. What about the 100% electrification ratio? In both dasar skenario and inshallah skenario, 100% electrification ratio will meet in 2025. On the other hand, alhamdulillah skenario will 5 years late. In 2030, it will be 100% electrification ratio, and of course, it was our hope together. In renewable energy share in energy mix 2050, in dasar skenario only 5.5% renewable energy. Inshallah skenario consists of 33.8%, while alhamdulillah skenario goes to 21.8% of renewable energy in energy mix in South Borneo province. I think that's all our presentation today. So I thank you for your attention, and let's coming to discussion session. Thank you very much.
Okay, thank you from Mr. Rizal Hadi and Mr. Pinto. Can you give applause to Mr. Rizal Hadi and Mr. Pinto? Okay, you see in the presentation is very uniquely. I think the name of the animal on your presentation is bekantan. It's only in Indonesia, I think, in the only on Borneo. So, in this presentation, I have so interested about your scenario about the Insyaallah and Alhamdulillah scenario. Why do you choose about the Insyaallah scenario and Insyaallah scenario? Because we know about the Alhamdulillah, the meaning is the price of the God, and the Insyaallah is like the expected the cure about the future plan of the God. Can you explain to us?
So basically, the idea is that inshallah is you know that we hope that we could do the target. So that's why we call it inshallah. It's the same with optimist scenario. Well, alhamdulillah, well, anything that happened, we should say thanks to God. That's why we choose terms inshallah and alhamdulillah in our scenario.
Thank you for Mr. Pinto. Okay, the second part we have a question and answer session. So the first question is from Mr. Vicky Prasetya. Can you stand come to us? Okay, join with us. Okay.
Thank you for opportunity, Mr. Rizal. I have one question to Mr. Rizal Hadi and Mr. Pinto. In your opinion, what are the strategies that you will recommend to the government in order to reduce the number of energy demand? Okay, this is my question. Thank you.
Thank you for Mr. Vicky Prasetya. Okay, directly answer from Mr. Rizal Hadi or Mr. Pinto. Want to explain? Okay, from Mr. Pinto.
Okay, thank you, Mr. Vicky, for your good questions. Firstly, I'm not saying that I will recommend this to the government, but I would like to see it from the government point of view. Basically, there are so many ways in how our government could force or push the energy demand to be reduced from any of the sectors, household sectors, industrial, public, or something else, or even the transportation that we not concluded in our project today. Firstly, there is a term that government could conduct the energy conservation. So this will apply in household sector, where the government could change the user behavior in using energy demand. You know that like turn off the lights when it's not used, turn off the air conditioner when there's nobody in this room, and something like that. So the government could point could change the behavior by use a policy or making the policy that will reduce the energy demand from this household sector. What about the public sector? What about the industrial sector? This is more complicated one compared to the household. So the energy conservation comes to the technological or the systemic way. So I've ever heard that the government of Indonesia had already planned to use an ISO rule. I don't exactly know how the government applied this policy in industrial and public sector, but I believe that these two steps could be a perfect plan for government to reduce the energy demand in household sector, public sector, or industrial sectors. So that was my opinion. So actually there are so many ways others than my opinion. There are a million ways that the government could do to reduce energy demand. The problem is we as the user of the energy. Thank you.
Back to Mr. Vic again. The problem is we use the energy. So this right, Mr. Pinto? Okay. The second question from the Mr. Guna. Okay. Take your time.
Okay, thank you for this time. I wanted to ask one question, two questions. Based on your result, the electrification ratio of the Kalimantan Selatan will reach 100% in 2025. Is there any surplus in energy supply after this period? And then where it will be used the future in the inshallah scenario is this it. Thank you.
Okay. Thank you for Mr. Gunabangun Prasada. I have the second question. So I think a direct answer from Mr. Rizal Hadi. Okay, take your time.
Thank you for the nice question from Mr. Guna. As we see in the conclusion, we tell you about the 100% electrification ratio is in 2025 by the inshallah scenario. We think that is our opportunity to get 100% electrification ratio in 2025. The surplus of energy will be sold to another province, such as Central Province of Kalimantan, Central Kalimantan. So we make an interconnection like in Java Bali distribution. Maybe we can call it Kalselteng interconnection. So the surplus of energy, especially at electricity, can we sell to the another province. I think it's enough. Then we make it distribution line to the central province of Kalimantan. Okay. I think
Okay, nice answer from Mr. Rizal Hadi. So I think the from the Papua Barat too, explain about the electricity demand and energy mix, and then the conclusion about this presentation about the in business as usual scenario have about 5 gigawatt hour and alhamdulillah it's about 6 or 6. Can you correct me if I'm wrong? About the business as usual have a 6 gigawatt hour, and alhamdulillah it's like praise of the God, 5 gigawatt hour, and inshallah it's very optimistic, like 7 gigawatt hour. I think because you choose about the South Borneo because have so many problem about the electricity, I think, and for so many trip in the one maybe about 15 or more about the 15 in the trip in the South Borneo. This is our problem. So we hope our project or our conclusion in this discussion, our group, making of some energy policy to our government or province. So this is the end of our discussion. Give applause again to us. This goes in. Assalamualaikum.